Thank you for watching the Housing Oregon YouTube channel. Be sure to join our network and get involved in the work that we are doing. If you can, please like and subscribe. It helps us build this channel, which serves as a platform to communicate with our members. This video is part of our 2025 annual conference. We're looking for folks to be on the conference planning committee. Please email info@housingoregon.org. My apologies. The first part of the recording for this workshop got cut off and there was a technical glitch, but it picks up right at the community engagement part.
So long. And Mary's Woods next door is a senior housing, senior development run by the sisters, felt really engaged in what would happen there. So we knew input had to be early and often. So we started off that process. Initial design studies really looked at across the whole campus, where should the building be? What type of building should it be? So engagement early on was really just about that. And we ended up settling on a site in the back of the campus, which is, really took over the footprint of some dormitories that were going to be demolished. So it seemed like the smart move, not impacting a lot of the campus because these buildings are already there. And it had just a nice shape to kind of embrace the rest of the campus. We could open up community space to face the rest of the campus. So that worked out well. And then, yeah, so the engagement process, and go into a little bit more on the next slide. Yeah. So it started with the sisters asking the community about just what our priorities for the campus, and that they kept hearing affordable housing. So that started the engagement with Mercy Housing and the project itself. And then there was a rezone process to get affordable housing allowed in this campus zone. So that was the next part. And then in 2020, 2021 is when Carlton Hart started getting involved in the design community engagement. We had a design focus group, which was not only neighbors, but also educational leaders and other leaders in the community to get input on what people wanted to see there. So we had 4 meetings with that design focus group through fall of 2021. And then that led to a bigger community meeting that's part of the land use process as well. And that led to this. These are the results of that community survey. So affordable housing, 66%, so good there. That was already the plan. But the rest of it, the next 2 items were environmentally friendly and sustainable. So those conversations about PHIUS or some kind of big sustainability goal had been percolating through the team the whole time, but didn't know about funding, didn't know what we could reach for, that sort of thing. But the survey really kind of brought it home of, this is what everybody wants. Let's see how we can make it work. And I think we kind of cemented it for the sisters. So they found a way to make it work. And then the other big item there you see is preserving open space and landscaping. So again, that decision to kind of go with one large building, which was something the design focus group talked about a lot because there was some nervousness about it, also was really the best approach in terms of preserving the open space that they also really cared about. So from this community engagement meetings, got to the project goals determined with Mercy Housing Northwest and the sisters, providing long-term housing for families, open space, accessibility, blending in with the existing campus, sustainability, and then long-term stability for families. So to get into what that meant for design, as I mentioned, there's a lot of interest from the community, a lot of kind of pressure to show what affordable housing means now and not what some perceptions of it are. And then, with the community engagement, I said we had already settled on kind of this larger building form, so there was a lot of discussion about how to make it fit in with the rest of campus. So the campus had some bigger buildings, but it's also surrounded by single-family homes. So there was some kind of non-negotiable design things we ended up with. Brick, for one, it's a campus, had to match the brick, that was everything else. But also the shape of the building, so we felt like a sloped roof form is really important to match the aesthetic of the neighboring buildings to kind of fit that more residential scale. Sharon will talk later about some complexities of that with PHIUS, but that was a decision that we kind of baked in early and felt like we really had to stick with. And then part of that design process was really looking around the site and finding connections, things we wanted to bring into the building. So this slide shows the Marys Woods campus that was just right next door. So, similar building size, some similar details that we carried through. And then here, this is within the campus, and there was a variety of architectural styles to respond to, which is really fun. So just kind of, spent some time walking around, seeing things that we could carry in, and what similarities there were, even though there were different periods and different styles on campus. So things like the pitched roof that I already mentioned. It seemed like every building had some kind of interesting little pattern in it, which was fun to find in each one, and we kind of figured out what would our pattern be. And the brick that I already mentioned, kind of the relationship of windows to walls, shapes of windows. So yeah, some nice little pieces to kind of build in and help define that form after we had the community engagement process to set the main standards, the main goals. All right, and then while this was happening, the PHIUS decision was happening. So I will hand it off to you guys.
Thanks. So the PHIUS decision to go PHIUS on this project was made quite late in the design process. I mean, it was pretty much a fully baked design prior to that idea really being fully committed to and the funding piece falling into place. However, we sat down and thought about, well, what does it take to get there? And these are the basic tenets of PHIUS, or passive building in general, but air control, thermal control, moisture control, creating indoor comfort for the occupants. And we realized, and we have on past PHIUS projects and passive house projects, that this really aligns with what Walsh Construction's quality program has been about for a long time. We started off with creating durable buildings as being our main goal. And once you create a durable building and trying to keep the water out, you realize that all of the measures that you implement in order to do that gets you on the path to all of these. So while it is still a lift to get to PHIUS, we were on the path already. So it was like, how do we make this project even more so all of these things? And air control was a big one, and one we have quite a bit of experience with. And so we had a couple of different options here. We've done liquid applied and self-adhered membranes, and this is sealed sheathing. We've used this on a couple of projects, specifically on some other passive house projects. And this works really well when you have full access around the buildings. So we were able to use a tape to seal the seams of the plywood, and then the Tyvek serves as the WRB that's required over top of that, but really also as a double measure for your air barrier. Some of the other parts of air sealing are, and I'll get into a little bit more, the roof form and the massing, and then also the duct sealing. And for passive house, the requirement is 0.08 CFM per square foot. And our final air infiltration for this building was 0.049, as you can see up there. So we got under it by quite a bit, and we were actually even better than that by about half before we put the storefront doors in.
Where do we end up? Sharon makes a T-shirt with the tightest buildings that Walsh has ever done, and we were
fourth or fifth.
I think it was second, is what I remember. Yeah.
We were second, and then we added storefront doors.
That's right.
So, like Melissa said, we had the form already, right? And the form, the massing responded to the campus and the design needs and wants of, not only the unit layout and the function of the building, but the rest of the campus. And so what we had with that, where we landed, was a sloped roof form. We had some height limitations as well. And we needed some place to put mechanical, so we ended up with a roof that has kind of a gully in it. And so we have a flat roof in the middle and then sloped on the sides. So from the ground, you get the view of a sloped roof. This was a little bit not traditional, I guess, in some of our typical air tightness methods. Usually you either have one or the other. And so in a typical vented attic, we would bring the level of air tightness across the ceiling plane, so not up at the roof. And here, we wanted to make sure we had continuous materials that connected all the way through. And we've done this kind of design or a vented attic anyways with a couple of different methods, and we really wanted to use continuous materials on this one. So you can see the transition points where we got into some non-traditional details, but with the advanced planning and really looking at all these details, we were able to rally our installers to coordinate how the materials went together. And with Carlton Hart, as you can see, these drawings were included in the drawings and are from Carlton Hart. So it was awesome to get these diagrams and details to be able to serve as a tool to discuss with our installers how to actually implement these and build it.
Great, thanks, Sharon. And I guess just to pause for a second, does everybody know what PHIUS is? Yeah, sorry, we should have, you showed up to a seminar about a PHIUS building, we just assume, but PHIUS stands for Passive House Institute of US. It is a passive house standard. There are actually two that exist, Passive House Institute, which is a German, I believe, German-based organization. They're different, they have different requirements. PHIUS, in this case, which we adopted as the sustainability pursuit, is actually a set of requirements, like Sharon mentioned, air tightness, balanced ventilation, a lot of emphasis on thermal envelope, but it also has a number of other program certifications involved, Energy Star, Zero Energy Ready Homes, EPA's Indoor Air Quality Plus. So it is a checklist to rule all checklists that when we came into the project, once the decision made to go PHIUS, was to help the team understand all of the requirements, consolidate them to different, a lot of them don't necessarily apply to this building. And so one of the goals early on was trying to define the requirements for this certification. And, energy code these days does drive a lot of some of these systems that this building does use, but PHIUS puts it on steroids. For example, the ventilation system for the building. Energy recovery ventilators, which is basically a ventilation and exhaust system, and then it recovers energy in a box, basically, to reduce heating and cooling energy use in the building. Great technology. Most states are starting to adopt this requirement in multifamily development, so it's becoming more common. But PHIUS has very high performance requirements on the system, and it also has this air tightness requirement, which a lot of these systems, we have a diagram here. So most people might be familiar with ERVs that go in every apartment, and there's two ducts that go to the outside. Well, that's putting a bunch of holes in your building envelope that make it very challenging to meet that tight air leakage requirement. So early on, the decision, this was discussed, and that moved the team towards using a central ventilation system. And there's pluses and minuses of both. This is a really important topic to talk with your team about, because there's no perfect solution, in my opinion. But in this particular case, there were a lot of pluses for the central system that outweighed the in-unit design. One that, if we go to the next slide, will show, oh, yeah. I think,
Go for it.
yeah.
Yeah. I'll repeat the question since we're being recorded.
Don't make me
Yeah.
regret this.
So as a service provider and
Yeah.
thinking about low-income housing, the line that says it's a negative, energy to run system is on house meter, does that mean the people in the units are paying more?
No, it actually means the owner is paying for that part of the utility bill. The fans, you're paying for the fans. So wouldn't say it's a minus. For some developers and ours, it might be a minus, but in this case, it was not really a big part of the decision. So what this system resulted in, once the decision was adopted to go central for the main reasons of minimizing penetrations, other big one was getting a piece of equipment that can meet passive house level energy efficiency. It was very hard in the smaller ERVs that you might find, at least at that time. You know, the technology has been evolving and it's been getting better. And then once that decision was made, finding a place for all the ductwork that minimized things like fire smoke dampers and other considerations. And it ended up being quite intense on the top floor. This is a picture of the top floor corridor. But the team figured it out, and in the end, you can see air leakage of the ducts is another big consideration with central systems. And you know, the team was able to figure it out. This is, you know, there's lessons learned that we're going to talk about, but
Yeah, I mean, from the contractor's standpoint, this was one of the more challenging parts because I think PHIUS's requirement is that you test 25% of the duct work. I think was the requirement,
50%.
50%. And Mercy Housing said, hey, let's just get an insurance policy and we'll just test 100% of it. And so on 4 and then on 1, there was a tremendous amount of duct work. And so, you know, we're used to putting in the sheet metal, you know, insulating it, rocking it, we're on our way. You know, you're installing the sheet metal, you're sealing as much as you can, you're putting it under test, you're finding any little pinhole leaks, fixing them, retesting it, hopefully not having to test it again, and then you can go ahead and hang the drywall. So it just added quite a bit of time that I think that was something, you know, we haven't done. Can't remember how many PHIUS projects that we've done or passive house projects, but not a ton. I mean, we'd done one in Seattle that we tried to get lessons learned from. They put together kind of a mock-up unit. They tested it and said, hey, everything's looking good. And then they kind of just repeated that process. But the 100% of duct sealing just took a lot more time than I think we had anticipated. So.
Well, I was just going to add that the project in Seattle, the design for the ductwork was very repetitive, so we were able to do, like you said, a mock-up of one piece and then figure out our QC measures and test that one piece and then repeat it over and over. And this design didn't have that repetitive nature that we could do, so yeah, it made sense to go ahead and test all of it, even though it was a big task.
And I'm sure, you know, because I think last time we did this presentation, somebody said, why don't you use AeroSeal? And I can't quite remember why that decision was made, but I wish we had spent maybe a little bit more time. Just the idea of pumping a bunch of goop that clogs a bunch of holes into a building didn't make anybody super comfortable. And so we just went with a little more traditional method of sealing the duct on the outside, so.
That and the fire smoke dampers,
Yeah.
they have known leakage points of how they operate, and so you can't seal part of that, but you seal everything else, and then you're allowed a little bit of leakage for that.
In the end, though, I think it was a good investment because this system will be here for the rest of the life of the building. So the tighter it is, the less energy it's going to use overall over the long term, similar to building envelope investments. So the other benefit of centralizing was the opportunity to use better energy recovery ventilation equipment. One of, not only, there's two aspects going central. One is, the easy one to understand is you can add cooling. You can add a heat pump that can actually heat or cool the air. And in this particular building, that is the only active cooling source of the building. The apartments do not have air conditioning. They have ports, or people can hook up portable air conditioners that they like, but this ERV does cool the air. And this chart is, forgive me for, this red line kind of represents if you don't have cooling in the ERV. You can get, you know, on a temperature when it's 90 degrees outside, your inside of your building is basically going to be 90 degrees without cooling. But with cooling in the ERV, this demonstrates you can knock maybe 5 to 10 degrees, probably more like 5 degrees off that peak, which is a significant thermal comfort benefit. It's not thermal, it's not full cooling. and it should not be expected to be, but it can really help improve the comfort of the building. So the other kind of major system that this building used, which was somewhat novel at the time, but much more common now, is central heat pump water heating. So it's an all-electric building. So there are no gas boilers for water heating. This happens to be a system by Mitsubishi. This was, I think, the 20th system put into the US, even though it's been available abroad before that. So it is very high, very efficient, way more efficient than electric resistance. But you can see it has quite a bit of equipment involved, so it's something the team really needs to wrap their head around early. We have the heat pumps on the roof. We have some big storage tanks and a room for everything in between. So it is, as far as I understand, working great. And most of our experience with commissioning these systems is they do work well if they are properly designed and commissioned. And this is a good picture. This is not showing all the photovoltaics that are on the roof now, but it shows by putting all that ductwork within the building, which for central systems, otherwise it would be on top of the roof. It really cleans up the roof, making that space available. So that's the other kind of major benefit of centralizing and keeping all that ductwork within the building envelope. And the ductwork will last much longer, and you won't have to remove it when you re-roof. You know, there's all these benefits of bringing that ductwork into the building that I think this building will see in the coming years.
So out of this project, we had a lot of different lessons learned, and as we were all chatting about them and building this presentation and others, we realized that a lot of our lessons learned had a lot of overlap. And where they overlapped or were the exact same thing, they were really, it was kind of interesting because it was maybe the same issue, but from different perspectives. And I'll let Melissa get into this about the foundation and structural details.
Yeah, so part of PHIUS coming on in the middle is we'd already made a lot of decisions, and we went back and revisited a lot of them, but some of them kind of kept like, yeah, that still works, right? Then found out later it didn't. So here you can see the foundation. So like a lot of our projects, we had planned on insulating the slab on the interior side of the foundation of the stem wall. And if you look here, all those red lines and blue lines, those all intersect that wall. So PHIUS allows some thermal breaks, but that was going to exceed the allowable percentage. So during construction, a new calc was run, and we realized we had to make a change. And so then we ended up adding insulation on the exterior of the wall, which I'd say was much easier to do in detail than in reality. But it solved the problem. Unfortunately, our contractor, our on-site supervisor, was okay with all the different flashing origami that had to happen to cover that. Yeah.
Brian, I think this is you and I. So I'll let you start. So this project was really right in the middle of COVID, so we had a lot of supply chain issues. You want to talk about the electrical switchgear was probably the champion of
And
that.
I think that became problematic because we did find out after the start of construction that we had to add an electrical service. And that was, I mean, the building has quite an electrical draw. It's all electric, and you saw some of the mechanical systems that run off of that. We've highlighted that lessons learned in the past, but it may have been a unique situation that we were in based on the location of the project. There wasn't, PGE was utility, and there wasn't adequate service in the area, so we had to bring in an additional service and use step-down transformers to be able to convert that to something that we could use. So you find that out late in the game, and then you place the order for the additional gear. That can become problematic. I mean, I don't think the electrical switchgear is necessarily a COVID era challenge. I think it's going to be an ongoing challenge that we experience on all of our projects. So, I don't know what could have been done to investigate that further on the front end to identify that issue, but we found ourselves in that situation, and Aside from switchgear, I don't recall.
Windows. So
Oh, yeah.
our windows were also a supply chain delay that actually led us to choosing a different, or going with another window manufacturer.
Yeah.
Worked out completely fine, and I think we're grateful to have several local, between Vancouver, BC, and out to the eastern side of Washington, several local providers that can fit the bill. But yeah, that was one change because of the supply chain issues. The other points on this slide, I think, were provided by Chris. I'll call on you for the one of them there. Okay. As David talked about the centralized ERVs, so Chris Bendix with Mercy Housing was intimately involved in the project. But one of the centralized ERVs, one of his points was that they work really well. However, he's a little concerned about the single point of failure. Can create some operational challenges if that is to go down. Yes, it's one thing and you're not having to go into every single unit, but it's one big piece of equipment serving a very large portion of the building. The other thing was that the ERVs are proprietary and can't be serviced by on-site maintenance staff. And that does present higher costs. As this equipment becomes more and more sophisticated, so do the service providers for that, and that's something that I think owners, unfortunately, are having to plan for. And then the other thing, and we touched on this earlier, centralized or the tempered cooling is not as effective as I think everyone had hoped. It sounds great to take it down 10 degrees, but when it's over 100 outside, it's not effective. And I don't know if you have anything to add on that part from the owner perspective. Or tenant perspective.
I'll jump in, yeah, I guess, because I've been intimately involved in this recently. When we talked about switching from, for instance, VPI to Initech, which is ultimately what we used, Initech, if you're familiar, has got the tilt-turn function. So we've worked with VPI for years to be able to have those window ports so that people could, during very hot days, could hook up a swamp cooler and get that exhausted out. But these windows don't have that. Initech doesn't have that option because they're much larger openings. And then obviously we couldn't put in the in-wall ventilation like we've done at other projects because, again, you can't introduce a bunch of holes into the exterior of the building. So it becomes challenging from a climate within the building perspective.
And on the air tightness front, there was an added cost for air tightness and going to the sealed sheathing and doing a lot of other non-traditional details. And how Chris put it was that it did not make up for the lack of in-unit cooling. So he was really wanting that to be part of the building after the fact on one of his lessons learned. And I know that's a requirement for Portland now. The added cost for air tightness, what we're seeing in subsequent projects, and I think the Mercy Greenbrae project was one that we looked at doing PHIUS, and the added cost for air tightness the delta on that has actually decreased significantly, and there's a few reasons for that. The materials, in order to get to that passive house level of air tightness, are more plentiful on the market. There's a lot more materials that are locally available to us that will accomplish that level of air tightness. Also, the installer base is more familiar with installing those materials. So while labor costs have not gone down, the familiarity with the products, we're not seeing that like, oh, I've never done this before kind of thing. And so on that subsequent project we looked at, and just in rough dollar signs, the cost to go the upgrade in air tightness was insignificant versus the added cost for in-unit cooling. So that's kind of the next challenge. How do you provide that in-unit cooling without making a lot of holes in your building? And then the pros and cons of the centralized versus unitized, or different options in between.
So one of the lessons learned was, I think, you saw how complex the duct system was in the previous slide, and this is an example of another building that did pursue and get PHIUS certification in Seattle that Walsh built. And it shows another approach where more upfront design coordination was done to including 3D modeling of the duct systems. And I think the takeaway for me when I, comparing the two is just that additional level of planning can help avoid some of the, crossovers and things that can happen, especially on that top floor where you have a lot to coordinate. So, Brian or Justine?
I can help.
I'll kick it off. This is really just to drive home the point that there are trade-offs, and like you can't get it all, or it's very, very challenging to get it all. So in this case, we had air tightness, it was cost-effective and energy efficient, but we don't necessarily have unit cooling, which retrospectively, like, we wish we had a bit more of, especially considering that on our grand opening, it was well over 100 degrees, so it was toasty.
Well said. I think that drives it home.
Yeah, so to kind of finalize the lessons learned for the project, PHIUS is not, I know that we were in the situation we were in. The sisters added project funding to accomplish PHIUS, but really PHIUS needs to be something that's decided as early as possible. I think that the thing that I learned on the project is that I thought it was about enclosure, it's going to be mechanical, but we were really talking PHIUS throughout every phase of the project. And for the design team to have to go and find every single little place where PHIUS is impacting the design is extremely challenging. So, like the testing and balancing spec was kind of, pretty similar to what we see on every project. And, we start to go into verification, and the PHIUS requirements were actually quite a bit higher on the testing and balancing side and the required CFM. So there's a lot to it. It's very complex. And so the earlier that you decide that you want to do it, the better and the more chances you have to be successful on the project. The other one was trade partner selection. Some of the installers were already selected that we had. On the electrical side, it was design build, and in the business that we're in, most of the projects that we do have a minority women-owned emerging small business requirement. So we work with a lot of small businesses, and a project like this, every project's got something complex about it, right? It's a big slope site or tight site constraints, and on this one it was the complexities in the MEP. It really is, and so having not taking any kind of, and that's hard for a small business that doesn't have a lot of experience in this type of stuff to go and execute. So yeah, on the MEP side, just absolutely critical with somebody that's familiar with PHIUS, that has potentially done PHIUS before, and can go out and execute the job.
And I'll give a shout out to our site superintendent, Pete, who is our longest term superintendent at this point. And you might think that he's very rooted in traditional building methods, but
Which he is.
But what he is really an expert at is communication and making sure that what is talked about on the design side and is in the drawings is communicating to those in the field who are actually building the building. And a lot of these concepts were new to him after 30 plus years of construction experience. And to see someone like that be able to embody new methods, new ways of doing things, taking a scope like mechanical that has really seen such advancements to where now it's a very, very technical application where it didn't used to be. I witnessed him several times sitting our installers down and saying, okay, we need to do it this way and this is why. And I think we were pretty successful. He was very successful in the field in doing that. So it had a lot to do with communication and doing that QC all the way through the whole project on the making sure the goals were implemented by everyone on the team. And this is our on the left here is our in-house enclosure installers, and looking very happy after our first air test where we got something like 0.02 without the storefront doors. And then on the right, our mechanical guys dropping that unit in.
Yeah, so this project, it was interesting to me because it looks just like every other project that we build. It's a 4-story wood frame structure, but it couldn't have been a lot different. I mean, it was a very, very challenging, like I said, along the way. And we talked as a team, the best thing that we could do is just go right into another PHIUS project because we're ready, and we learned a lot on this. But these are my 3 sons out of the job site, obviously not wearing pants like they should be and adequate footwear or safety glasses. But this was on a weekend, so I thought we could get a pass. But it's really projects like this that are going to inspire the next generation of builders as we start to become more environmentally friendly and focused on things to make these projects, make these buildings last, far longer than we're all alive. So now we are going to move into the questions stage. So I will come out with a microphone because we are recording this. And but yeah, if anybody's got any questions. First hand I saw right there.
Thank you very much. I'm curious about the testing, airtightness testing in particular. Did you test in stages, and what did you figure out in the initial testing? Where it's that you then solved by changing the detailing or the implementation? Just on recent projects that I've worked on, it seems like the building can't be air tested until it's too late to actually do anything about it, because then all your interior finishes are in and you're just crossing your fingers. So it sounds like you've got a tight building. What were the steps to getting there?
Yeah, so this is about our 4th passive building. And as you can see here, in this picture is right after we did our preliminary test, and you can see there's some brick on. So if we had an issue behind the brick, that wasn't coming off. But the rest of the building was pretty open. We did have some cladding on it. And the reason I bring up that we have 4 or 5 projects under our belt was the very first passive house project we did the entire enclosure and then tested it. So we had a gap in the schedule. And we planned that in because we weren't sure if we were going to get there or not. And so when we do a passive building now, we look at that schedule. There's usually some overlap. We needed to keep going with brick. But we made sure that we did all of our QC and that the areas behind brick weren't anything tricky that we were questioning. And then when we do the test, this is right when the sun came up. We were actually on site at about 4 in the morning so that we could run around with infrared cameras. So we heated the building inside, and we kind of had temp power on this project because of the electrical service issues. So we heated it up as much as we could. We did a really early morning test, went around and reviewed it with our IR cameras. We found a couple thermal bridges. We found a couple of open windows. And then we came back. And the difference between the 0.02 and the 0.04, the elements that were added that weren't just taped up were storefront doors that were actually 2 sets of double storefront doors, so they did not have a astragal in the middle. So we knew that those were going to be leaky, but that's our access point, right? So we can't, that is what it is. The other thing were the ERV connections on the top. That was something that we found that was a little leaky to begin with, and we ended up doing a lot of spray foam touch-ups on that where those ERVs sat.
Hi, sorry if this has already been addressed. I was just a few minutes late, but I'm wondering why you guys did PHIUS. Was it a mission alignment? Was it a funding source, or was it both?
Doing sustainable projects is both an organizational goal of Mercy Housing, but also in this case, it was really driven by the sisters. So they wanted to see it done, they wanted to push the envelope, and they put some money to it.
Hi, awesome presentation. I'd followed this project for a couple years, just like on the DJC. So cool to see a presentation. With the DOAS system, I'm curious, my assumption is that one of the exhausts is in a bathroom. Have you guys found that DOAS can meet that moisture expel load? Or are you guys having moisture? I mean, you're at 10 times better than the code envelope. So are you guys experiencing some moisture issues in the bathrooms?
Yeah, that's actually Justine of you.
That is a great question. Would love to.
If we were having moisture issues, I would hear about it. Yeah, for sure. Yeah, I have not heard of any moisture issues in the bathroom, so.
We've been hesitant to be like, oh, this ERP is awesome, the system's great, can it meet the moisture load?
Yeah.
But
So far, so good. I mean, there've been people occupying the building since May of last year.
Yeah.
So we've made it through a couple of seasons and no issues so far. I'm going to knock on some wood right now. Yeah.
Double knock for me.
Yeah.
Hi, thanks. Thank you. Yeah, very cool building too. But I had a question. Given the problems you've had with building comfort, the high temperatures, is there anything that you would have done or you think you should have done to solve that?
Probably starting the decision point earlier, but I think that they would maybe have some more technical insight. I don't know.
Yeah, and I'll just say, I think that Venn diagram really, really kind of hammered the point home, is that it's so difficult, with PHIUS, and anytime you're trying to do an airtight building, and you really can't have all these penetrations through the wall, and there probably is a system out there that could meet all of those, but then you don't have the cost effectiveness, and it being affordable housing, and we're already stretching to be able to reach PHIUS. There may have been a different solution, but I don't know if it would have been any better. It's complicated.
Yeah, and I think that the PHIUS has thermal comfort criteria, and I wouldn't say it's perfect by any means. It passed the cooling thermal comfort criteria with the site shading and the little bit of cooling in the ERV, but as you can see, with the experience is not that you feel comfortable in the summer. And so there are PHIUS projects that have cooling, obviously. There's a lot on the East Coast. It just comes at quite a bit more cost. And then the air tightness, like we've looked at with Mercy, putting cooling in a PHIUS project using package terminal heat pumps or other kinds of heat pumps. And also, if everybody's been following it, there's been a big change in air conditioning equipment with refrigerants in the last year. And that's made it another big challenge to put refrigerants into buildings. So there's a lot of challenges, and I wouldn't say there's perfect.
Yeah, I was just wondering if you thought you should have added more insulation, for example, or better windows.
So, yeah, kind of. If you think about the Pacific Northwest, what we've been able to do here, we've been able to get away with some really cost-effective systems, right? Opening a window and a cove heater has worked for a long, long time. So when you get hit with, hey, you got to add a really sophisticated cooling system to your building, it's the shock factor. If you go to Texas or other hot climates, the shock factor isn't there, right? Because they've had to provide cooling over and over, and they're figuring out how to do it cost effectively, but also in an airtight situation. We're not there yet, and it's still a big lift for us. So one thing that is kind of a point of pride for this building is that we have a 2x6 wall. What was it, R30 or R23, and dual pane windows. So you can do PHIUS cost effectively, with really regular materials. Now, if you wanted to reduce that cooling and heating load even more, could you use a 2x8 wall with more insulation? Sure. Could you use exterior insulation? Sure. Could you use triple pane windows? Yeah. Everything you add, right, every material you add costs more, adds cost to the project. And so I think it's finding that balance of what are the cheaper things to add to the building that mean more. And that was the example of the Burien project. I think the cost to get to air tightness has really become insignificant compared to the mechanical upgrades.
One small other thing that I would add is that PHIUS sort of relies on the assumption of airtightness, and so there is an element of tenant education as well, especially because in this environment we're used to opening windows, and so that sort of throws the system off if people are used to being able to open their windows, but you can't really do that in order for it to function properly.
Hi, I've got a question for Mercy Housing. Given this experience and honest answers only, would you do it again? Why or why not?
Great question. I practiced this one. I think it depends. Like I mentioned earlier, it is an organizational commitment. Like we do want to do PHIUS projects when it makes sense. We do really care about airtightness. We care about all of these things and want to push it forward. I would reframe the question, I think, to taking the lessons learned and like the most high impact lessons learned to every project and not necessarily always doing PHIUS for all of them. But, you know, when it makes sense, and if we did, it would be with this team because we learned a lot.
I'm curious if you know what the EUI of the building is and if that is inclusive of the solar array, what size array was installed?
Yeah, we haven't, that's one thing that's something I think we made note of trying to track for the next presentation. We don't have that. Yeah, I don't know if you have any
And
anecdotal.
solar was added post-project too.
Yeah.
So not to take the easy out on the question, but it was not part of the original base scope, and it happened after after Mercy occupied the building. Yeah, but I don't know energy usage.
It was in the high teens was the design target. That's a model, and you know, as Justine mentioned, people open windows, and there's still some kind of final commissioning things that are happening to get the certification. So that is, you know, I guess that tracking process is something that still the team is going to work on.
Very well done. This is a very impressive project. My question has to do with budget and timeline and the impact. Do you have like a percentage above base for both of those?
I'm not sure on timeline, but on budget, what we found with passive house projects, with our very first one, so we've done 5 so far and haven't yet had the opportunity to do one where the passive measures or PHIUS was really baked in and committed to up front. So all of our data is varying levels of those tenants being added. Our very first project, Orchards at Aranco, the first phase of that, saw about a 10-11% cost increase to go to passive house. The next phase of that, Reach, very much like Mercy, said, let's take what makes sense and forego the certification, but let's just do what makes sense and put that in. So it was, you know, somewhat baked in. And then PHIUS, that was about the time PHIUS was coming online, and we saw about a 6% increase of cost there. PHIUS actually came to us and said, pretty sure your project is going to pass and make it as a certified project. And so we went ahead and had them do the model, and it did, and we got a certification out of that one. Hobson Place in Seattle, again, PHIUS was applied after the fact, and we saw, again, about a 5 to 6% increase. And at this point, we're looking at a lot of projects, and we can really hone in how to create efficiencies, whether it's with unit layouts, stacking mechanical, deciding centralized or unitized, to where we can push down some of the other costs, whether it's framing, electrical, drywall costs, by being really efficient with other major systems of the building, to where we can add back that 5% pretty easily and come out with a project that is via certified level without really adding much to your project. We'd love to be able to do it.
I'm going to jump back onto the conversation maybe about solar. Does anyone know how much that solar offsets the cost of the house load? I work with Energy Trust of Oregon. I'm seeing a big house load. So that would be one question if you've done that. And do you have any indication what the utility bill is for the tenants, maybe through a utility allowance study? Or that would be my question, sort of twofold.
Yeah, we did, Mercy did use a modeled allowance on this project, I believe, so I don't have those numbers. Maybe we can exchange info, or, we can connect. Yeah, go ahead.
We are only in our first year of operation, so I feel like it's hard to say right now. And we also have a lot of all-electric buildings, so I don't know, it's sort of on par with a lot of those. It did come in under budget in the first year, but, keep in touch and I'll keep you posted.
To your awareness, are there any funding sources or streams that don't pair well with PHIUS?
Not to my knowledge. Or, yeah, you said that don't, or?
Sure, yeah, because the most restrictive funding rules cover the whole project, right? And so is there anything that, if you were to use funding from this source, that would make it extremely challenging?
Yeah, I'll pass it off, but nothing really comes to mind, and the funding was pretty straightforward and simple in this case.
So nothing that I have heard of either, and actually to the opposite. There's, state of Massachusetts has actually adopted PHIUS as a path to compliance with their energy code. And I think they're requiring anything over 12,000 square feet to comply with that. I think Pennsylvania had a incentive program for passive house multifamily. So it's actually a lot to the opposite. A lot of jurisdictions are starting across North America to say, if you can meet PHIUS, don't worry about all of the other things. Like, go with this, and you can do that. That is the case also in Washington State on residential side, so you can go PHIUS.
And I believe it was through ORMEP that you had a utility incentive as well for the project, and I think that was close to $250,000 or so.
And then OHCS, well, PHIUS isn't one of the three, standards that they list. It was no problem at all to just say, we're doing PHIUS instead and get that approved.
Real quick question. So we're verifiers. We do a variety of stuff. We don't do PHIUS, and I'm curious if y'all have heard, because Energy Star is going to go away, 45L is gone. PHIUS is based off Energy Star. Have you guys heard from them how they're going to respond to this change, or how's their program changing?
No, I haven't heard any details. They have their own set of requirements. I think, if anything, they'll just roll them into their program. And at the end of the day, it's the PHIUS verifier that verifies everything. You don't have separate Energy Star and other verifiers involved. It's just the single verifier.
Any other questions? Oh, yeah, here we go.
I was just wondering if with a centralized system, there's an option to add cooling cost effectively, since you're not having to add it per unit, and if that's something that's been considered. And then kind of a corollary question is, since we know that summers are only getting hotter and that cooling's likely going to be needed in these buildings, has anyone looked at a cost analysis to say, all right, what's more expensive? Is it increasing the building envelope's energy efficiency, or is it adding cooling?
So this building had cooling in the ERV, and there's some challenges, there's some limitations right there. One is not a lot of airflow, so you're limited by how much air is being moved, and that limits how much cooling you can do. The other thing is the temperature of that air. Unless you insulate the ductwork, you're limited to something like a 60-degree supply air temperature. So that right there also limits the amount of cooling you can do. So with central ventilation, it is not a comfort cooling solution at all. It'll improve comfort, but it won't get you there. But I think It has to be in-unit cooling or where you need it. And unfortunately, building envelope doesn't help when the daily temperature is over 100 and the nightly temperature is in the high 70s, 80s, right? You can't cool the building down passively at that point. You have to have mechanical cooling.
Doesn't look like there's any more questions. Okay, well, thank you everybody very much for coming, and I think a few of us will be at the gala tonight if there are any burning questions on Passive House, but thank you very much for coming. See ya.
Nice job, everybody. Yeah. It's always nice to have that done.
I know, right?
So participants open the windows and it throws the whole thing off, and if it's too hot in there and the window unit that throws the whole thing off, then what was the point of doing sealant to that area? I mean, I don't mean to disparage us.
The certification is a paper time. That's the unfortunate. You can't tell everybody, hey, you can never have to do windows, or I know you're hot with kids, but,
And the windows have to open because of safety.
the windows open 4 inches.
Yeah.
Only 4 inches because of life safety. We even put on the upper floor.
Not that many humans can get there. So
Well, that's why, yeah.
Yeah, so it's not meant for egress? No, it's still.
Yeah.
Yeah, there's no egress,
Yeah.
so even on the first floor, the windows are not a form of egress, so they all have 4 inches.
4-inch openings, yeah.
Then why couldn't we close it out? I mean, like some office buildings or
It, I think it's code required, yeah, for residential. Well, it's, what is it? It's,
Like high-rise
It's an-
residential, you don't have to provide operable windows.
I think the mechanical requirements are different for buildings where the windows don't open, but I'm not quite sure.
I mean, the reality is, there's a lot of time of year where it's
actually
a good
nice.
practice to open the windows.
Yeah.
It's just,
I have a house that was built in the 20s, and when we
Yeah.
moved in, we didn't have AC, and then gradually we got unit after unit after unit, and finally we centralized the whole thing. Because Oregon, as you said, has changed over the past 20
Yeah.
years. And so, yeah, okay, well, thank you. Thanks.
Justine, I want to introduce myself. I'm Dean. Nice to see you.